Lesson 21. So we are on page 137, 8-7 math. So this is all of you except for the people I've already worked with, the 5 of you I already worked with. Okay. So we only have about 10 minutes left, so we're probably going to finish off with this math lecture and then we'll go on to break. So we are working with prime and composite numbers, and then we're going to get into prime factorization. So first off, what is a prime number? So a prime number, also known as a composite number, they have exactly two factors. So an example of that would be 7. The only factors of 7 would be 1 and 7. So that's all review for us. Another example would be 11. The only numbers that go into 11 would be 1 and 11. What would be another example of a prime number or composite number? Aries? 3, yep. A little bit bigger of a number would be 27. Oh, no. Yep. 29, no, 23 is the one I was thinking of. 23, 1 and 23. 29, that was the other one I was going to do. Yeah, Aries. 2, yep. 2 would also be considered 1. And then they have a chart of factors of counting numbers from 1 all the way to 10. So as you can see, 1, it only has a factor of 1. 2, it has factors of 1 and 2. 3, factors of 1 and 3. 4, you have 1, 2, and 4. 5, 1 and 5. 6, 1, 2, 3, 6, so on and so forth. All right, so prime number is a counting number greater than 1. Okay, we already went over that. Okay, example 1, make a list of the prime numbers that are less than 16. All right, so let's write out every number up to 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so I need to figure out which of those numbers are prime numbers. Which of those numbers only have 2 factors? Yeah, Bethy? Come on up and just cross out the ones that are not going to apply. Where did I do my?
Do a fun color.
Okay, here you go.
What color shall I choose? Actually, no. Is this invisible? Oh, yeah, that is visible.
Something red.
Okay. So, 4 is divisible by 1, 2, and 4, so we can cross that out.
Yep.
6 is also divisible by 3 and 2.
Yep.
So
that will not apply. 8 has 2 and 4, 9 has 3 and 3, 10 has 2 and 5, 12 has 2 and 6, and 3 and 4, 14 has 2 and 7, 15 has 3 and 5, 16 has 4 and 4.
I missed one?
Which one did you miss, Aries? The number 1. That's because the only thing that goes into it is 1. It's just 1.
So it's not a prime or composite?
Exactly. 1 and 0 would be the exceptions there. Those are in their own category. So our numbers under 16 would be 2, 3, 5, 7, 11, and 13. And if we went up to 17, 17 would also fall into that category. Yay! Hot dog. Thank you, Bethy. All right. Okay. Let's try prime factorization. Oh no, I skipped over example 2. Example 2. For example 2, I almost skipped it. List the composite numbers between 40 and 50. What are my composite numbers between 40 and 50? So I'm right. 40. Wait, does it want me to list 40? No, it says between. So 41, 42, 43, 44. Yeah, Courtney? Yeah, come on up. 6, 7.
You're still in purple.
Yeah, I know. I'm leaving it as purple.
No, that's fine. Remember, since you asked? No.
I'm a nicer person today.
Okay,
Yay.
so cross out the composite or cross out the prime?
What was that?
Cross out the composite or cross out the prime?
So cross out the prime numbers.
Okay.
We're keeping the composite numbers. Yep, that's it. So 42, it's an even number, so 2 goes into it. 44, same thing. 44 has 2 going into it, 11 going into it, 4. 45, it has a 5 at the end, so that means 5 goes into it. 46, it's an even. 48, an even. 49, it has 7 going into it. So all those numbers have something besides just 1 and whatever their number is. So those would all be our composite numbers. So prime factorization. What is prime factorization? William, can you read the definition of what prime factorization is? It says on page 139.
Oh, I can think of it. It's where you take a number and you list only the prime numbers.
Yes. So prime factorization, the exact definition they have written here, when we write a composite number as a product of prime numbers, we are writing the prime factorization. So you are listing all the numbers that multiply to equal that number. So yes. So we have 30. So I'm going to list all the things that go into 30 here. I have 1. I'm going to list it in a different way. 1 times 30. 2 goes in it. 2 times 15. 3 times 10. I'm doing it in out of order, out of numerical order. 3 times 10. 4 does not go into it. 5. You have 5 and 6. So that's it. So out of all the numbers I just listed, 1, 30, 2, 15, 3, 10, 5, and 6. So for the prime factorization, I need to list the prime numbers only. Which of those numbers are my prime numbers? William? 2, 3, and 5. And that is because 30 is not a prime number. 1 is not a prime number. 15, not a prime number. Same with 10 and same with 6. So 2, the only numbers that go into it are 1 and 2. 3, the only things that multiply to equal 3 are 1 and 3. And same thing with 5, the only things that multiply to equal 5 are 1 and 5. So those, and the way I would write this as my prime factorization would be 30 equals 2 times 3 times 5. And we'll get into later in the year why this is going to be really important. Oh, I don't think we're not doing it yet. Okay, so what's example 4 want us to do? Write the prime factorization of 100 and of the square root of 100. Okay, yeah, let's do that one. So, example 4. Example 4, write the prime factorization of 100 and the square root of 100. Okay, how am I going to do this? And I'm at the bottom of page 139, going on to page 140, where it talks about factor trees. We went over this last year in math. Yeah, it was kind of around, it was right before we were shut down. Yeah, Aries, come on up and do it. Yep, do it for both 100 and the square root of 100.
Oh,
And explain what you're doing with the square root one.
Okay, so the square root is, well, 10 because 10 times 10 equals 100 has to be itself. So that will equal 10, which is just 5 and 2. So is 5 is just 1 times 5 and 2 is 1 times 2. For 100, we just do this. I like doing 10 times 10 because it's easier.
So Aries, what are you making right here before we move on? So this little branching thing that Aries is doing, it's called a factor tree, which they talk about on the next page. So go ahead and keep going. So Aries is breaking down the 100 into something it's divisible by. So 100, he picked 10 and 10. He could have done 25 and 4. He could have done 50 and 2. And you're going to end up, no matter what, with the same result. Bless you, bless you, bless you.
That's fun.
And what Aries ends up being left with is 2 times 2
So,
times 5 times 5.
right?
Or 2 squared times 5 squared. I like that. That also works. We're going to spend a little bit more time with this lesson on Monday because I want to be able to dive into prime factorization, factor trees a little bit more. I didn't have quite enough time. Yeah, prime factorizations are very important when we move up and up into math. So I want to spend a little bit more time on this next week. So that's it. That's all I have for you guys for today. Keep working on your homework. You guys will still have you will still have study hall